Hello friends, and welcome back to another episode of Spilling Studio. My name is Sam, and doing a bunch of practice questions was the biggest help for me when I was studying for my exams. So each week I create 7 ARE practice questions designed to help you pass your next exam. There's one question per exam topic and a bonus question at the end, so stick around. Let's start off with practice management. An architect is in the process of writing specifications for the new construction of a local theater. In the specifications for acoustic paneling, the architect details the requested sound absorption (NRC), articulation class (AC), recycled content, and fire resistance class. What type of specification has the architect written? Proprietary specifications, performance specifications, descriptive specifications, or reference standard specifications? Feel free to pause here to answer. The answer is performance specifications. So what is with all of these specifications, and who cares? You do. Specifications are super important. They're how you make sure you and your client get exactly what they want. The best way to do that is with proprietary specifications. These specifications specify particular products or materials by brand name, model number, or manufacturer. This approach is often used when the architect has specific products in mind that they believe are essential for the project's success. However, it can limit competitive pricing and may not be suitable for all projects. Performance specifications are what you specify when you don't mind who makes the product, but the way it works or the way it's made is more important. Performance specifications outline the required performance criteria for materials, products, or systems without specifying particular brands or models. Instead, they focus on the desired outcome or function, allowing contractors flexibility in selecting suitable materials or products that meet the performance requirements. Descriptive specifications provide detailed descriptions of materials, products, or systems, including their characteristics, dimensions, and installation methods. This approach gives contractors more freedom to choose materials that meet the specified criteria while still ensuring consistency in quality and performance. And finally, reference standard specifications refer to established industry standards, codes, or guidelines that materials or products must meet to comply with regulatory requirements or industry best practices. This is all the abbreviations you've seen: ASTM, UL, NFPA, etc., etc. These standards provide a common basis for evaluating and selecting materials and products. Next up is project management. You are a project manager overseeing the construction of a new office building for a client. The project is currently in the construction phase and progress is being monitored closely to ensure adherence to the project schedule and budget. During a routine site visit, you discover that the subcontractor responsible for installing the HVAC system has used standard materials that do not meet the specifications outlined in the contract documents. Additionally, the subcontractor has deviated from the approved installation methods, which could compromise the performance and safety of the HVAC system. What is the most appropriate action for the project manager to take in this situation? Inform the subcontractor of the deficiencies and request them to rectify the issues immediately. Proceed with the installation as is, as long as it meets the minimum requirements outlined by local building codes. Notify the client about the observed deviations and deficiencies from the contract documents, and discuss potential solutions with the owner and contractor. Document the deviations observed and inform the subcontractor that they will be responsible for any costs incurred due to rectifying the issues as per the terms of the contract. Pause here to answer. And the answer is to notify the client about the deviations and deficiencies and come up with potential solutions. This is a contract-related question, and you may be thinking, but Sam, the question doesn't say what contract they're working under or what project delivery method they're using. I know, it's super frustrating, but on all of your exams, if they don't state the contract or the delivery method, then it's the traditional construction delivery method, which is design, bid, build, and they're using the standard AIA contracts that go along with that, like B101, A101, and A201. Keep that in mind, especially for project management and construction evaluation. So A201 states that the architect will keep the owner reasonably informed of deviations from the contract documents and any observed defects and/or deficiencies. This is also the exact statement noted in B101. And the third item the architect must keep the owner informed about are deviations in the construction schedule. While that one's not related to our question, make sure you remember that one as well when you're testing. Now on to programming and analysis. A couple is looking to expand their family with 2 children in the next year. Their house is currently 2 bedrooms and they would like to add 3 more rooms for their future children. Their property is very tight and the proposed addition will potentially extend 3 feet over the property setback. What should the homeowners apply for? An easement, a covenant, a conditional use permit, a variance? Pause here to answer. And the correct answer is a variance. A variance is used when zoning requirements do not address unique situations. I remember this by telling myself it's varying from zoning requirements. It's typically used when projects don't meet the required building height, setback requirements, floor area ratio, or lot size. To submit a variance, the owner would fill out a form, describe their requested changes, and submit drawings of the proposed addition. This is then reviewed by the municipal board, either the planning commission or the zoning board, for approval. There's a meeting that's held and it's public and they allow other neighbors and interested parties to make comment before coming to a final decision. So hopefully your neighbors like you. These meetings are typically few and far between, so if you have a project that may require a variance, get your request in early. We had a project where the local municipality only met once a month, and if you didn't submit your request by a certain time, then it wouldn't make it on their list for that meeting and you'd have to wait another month. This is the kind of stuff that can really delay a project, so make sure you're thinking about your local requirements during the early stages of design. An easement is a legal right to access someone else's property. A covenant places restrictions on the use or appearance of a property. There are a few different types and I'll cover this in the next video, so make sure to tune in. A conditional use is similar to a variance in that it's a deviation from zoning requirements, but it's specifically used for land use type. It's called a CUP, conditional use permit. The purpose is to allow zoning to impose special conditions on a project to make sure the development doesn't adversely affect the surrounding area. Moving right along to our next exam, project planning. And our question is, according to the International Building Code, which of the following are parts of the means of egress? Select 3 that apply. Common path of travel, exit, exit access, public way, exit discharge, or stair. Pause here to answer. And the correct answer is exit access, exit, and exit discharge. Means of egress is defined in Chapter 2 of the IBC as a continuous and unobstructed path of vertical and horizontal egress travel from any occupied portion of a building or structure to a public way. A means of egress consists of 3 separate and distinct parts: the exit access, the exit, and the exit discharge. A public way is a street, alley, or open land that is outside to a street and has been permanently dictated for public use. It's not part of the egress, but the means of egress must lead to it. Something I didn't know is that the space only has to be 10 feet wide, 10 feet deep, and 10 feet tall, which is the size of a standard office. I definitely thought that this would be required to be a lot larger than that. The common path of travel is a portion of the exit access that leads occupants to 2 separate paths of egress travel, each leading to 2 separate exits. I will admit I put that stair option in there to try and trick you. A stair could be part of the means of egress, but it would be designated as an exit access stairway. Not every stair is part of the means of egress. They are most of the time, but not always. So make sure to specifically answer the question. If it's wishy-washy, then it's probably not the right choice. A brief pause here to remind you that I post new questions every week, so please hit that subscribe button to make sure you don't miss out on a video. It also really helps me out, so thank you. Now on to project development. Reference the below masonry detail. Which element represents flashing? A, B, C, or D? Pause here to answer. And the answer is B. The primary purpose of a flashing is to prevent water from infiltrating the building envelope. It is installed at vulnerable points in the wall construction, which is wherever there is a change in material, like we see here between brick and concrete, as well as at any openings such as doors, windows, or any penetrations. It helps direct water away from these vulnerable areas. Flashing also helps accommodate movement in the wall due to expansion and contraction, which happens due to changes in temperature or moisture levels. Next up is construction evaluation. The construction of a new church has begun. The GC has just poured the concrete slab, but temperatures are expected to drop that night. At what temperature does the contractor need to take protective measures? 0 degrees Fahrenheit, 16, 32, 40, or 50? Pause to answer. And the answer is 40 degrees Fahrenheit. Construction typically stops or switches to cold weather mode at 40 degrees. Concrete can be poured at this temperature, but it must be heated to make sure none of the components have frozen. The concrete must continue to be heated for at least 7 days after pouring, which is during the early curing stage. After the temperature goes below 40 degrees, temperature-sensitive materials should not be applied or installed. So, what is the ideal temperature? Well, it's typically between 50 and 90 degrees Fahrenheit. Below or above this range, the concrete may encounter problems during curing and setting. Below 32 degrees, and the mix can freeze and compromise its strength and integrity. Cold temperatures slow down the hydration process of concrete, which is crucial for its strength development. If concrete takes too long to set, it may not achieve the desired strength, resulting in a weaker final product. Pouring concrete in very cold weather and then exposing it to sudden temperature drops can lead to internal stresses within the concrete, resulting in cracking. Cold temperatures can also reduce the workability of concrete, making it more difficult to place and finish properly. This can also lead to issues with the surface finish and overall quality. Overall, pouring concrete in very cold temperatures can lead to structural weaknesses, surface defects, and other problems that can compromise the integrity and durability of the concrete. It's generally recommended to take precautions such as using insulating blankets, heaters, or additives to maintain adequate temperatures during cold weather concreting. Wrapping up with our bonus question, which is, what should be incorporated at the center of a two-way road to ensure proper stormwater drainage? Drain inlet, inverts, crown, curb, or catch basin? Pause to answer. And the correct answer is crown. In road design, a crown refers to the shape or profile of the road surface. It's not flat like a tabletop, instead it's slightly rounded. You may have noticed a gentle hump in the middle of the road. Well, that is a crown. Roads are crowned for a few important reasons. First, it helps with drainage. When it rains, water needs to flow off the road to prevent flooding and damage. The crown directs water towards the edges of the road where it can be collected by gutters or drains. By having this slight slope, water naturally runs off to the sides, keeping the road surface clear and reducing risk of hydroplaning. So the next time you're driving down the road and notice a slight hump in the middle, you'll know that it's not just there by accident. It's all part of the careful planning and design that goes into creating safe and functional roadways. That's our questions for this week. Remember to check out the descriptions for a link to some of the AIA contracts covered in this video. I've also linked some of my favorite study books, so go check those out. Let me know in the comments what subject areas you're struggling with, and I'll do my best to cover it in the next video. Thank you all for joining, please subscribe, and good luck on your next exam. You got this!